Okay, we're back. Um, One of the things that I think is interesting about the emergent subject of software engineering is that as a mature technology, it's beginning to create what I call design patterns, where design patterns have specific problems that you're trying to solve and have specific names for the type of pattern. And these design patterns allow us to address certain kinds of problems that seem to occur often in programming. So these programming design patterns are things that people have written about extensively. One of the problems that we have is, well, what happens if you try and start a registry that listens on port 1099 and then forget that the registry is already running? You don't want to start two registries listening to port 1099 because you get a port in use exception at runtime. So one of the things you can do to make sure there's one and only one registry running at the time is to use a design pattern called the singleton pattern. What's the singleton design pattern? Anybody know? Yes, sir. Yes. It's when you only have one instance. One instance. So I'll give you an example of the singleton design pattern. It's a very common example, very common design pattern. Let's see if we have any examples already done here. Any design patterns? No patterns. I should probably make up a special chapter on design patterns. Yeah, that's funny. There isn't one here. But I'll make a new class, Java class, and I'll call it the singleton example. I guess I'll have to move it to the we make a new chapter. Let's call it chapter. Do we have a chapter 48? I don't think so. We'll call it chapter 48 patterns. And I'll create it. So in chapter 48, we're going to create the singleton pattern. And what we'll do here is we'll provide a method that says public static singleton example, and it'll say get singleton, and it'll return an instance of the singleton example. Returns an instance of itself. So this should be of singleton example type. And since this is a static method, it has to make reference to a static instance, which will be private. I guess we can give it the name S. And then singleton example S will be equal to new singleton example. So now when anybody calls singleton example.getSingleton, they'll always return the instance S, the one and only one instance of the singleton example. Is there any way someone could make multiple instances of the singleton example? Couldn't I instance this outside of the singleton example class? I could, right? So what can I do to stop that? How can I stop other people from instancing this singleton example? Yeah, I'll have a private constructor. Private singleton example constructor. And that's it. Now no one else can instance the singleton example outside of the singleton class, the singleton example class. Isn't that right? Could anyone find a way to instance the singleton example outside of the singleton example class? What if I subclass it? If I subclass it, I could certainly instance the subclass, right? Because the subclass could have a constructor, and the constructor in the subclass could be non-private. And then people could make instances of it galore. Lots of instances. How could I stop people from subclassing it? Yes, sir. Well, if I make it private, no one will have access to it. So that I want people to be able to have access to the class so they can gain access to the reference data type and also the method contained in the class, which is get singleton. So how am I going to make it so that people can't subclass this singleton example? Well, protected gives subclassers all the rights. So protected access means anyone who's an author of a subclass gets all rights. What else? How about if I take this class and make it final? If I make the class final, then you can't subclass it. So now with a non-subclass, because you can't extend a final class, you have no ability to make new instances. So what I have done is I've created a single instance of the singleton example which you can gain access to. And that instance will be the only one instance available. Can you think of any examples where the singleton design pattern might be useful to you? Or maybe examples of classes that use it. You've probably used, in fact, I think you have almost certainly used a class that makes use of the singleton pattern. Can you think of what that might be? What about math.sign? If you look at the math class, you see a final class with a private constructor. Why? Because no one should ever instance the math class. Why? Because all of the methods in the math class are static. And you don't want to override the behavior of the math class, because if somebody came along and said, geez, radians, I like degrees, guess what? Your compiler doesn't care. Your compiler sees radians as floating point numbers. It sees degrees as floating point numbers. And the answer will come back. It'll just be wrong. And it will take a long time for you to debug it. In fact, you'll be all pissed off at the people who overrode the math class and changed its behavior, because you'll never know why your code is wrong. You'll think it's you, but it's not you, it's them. Yes, sir? Yeah, it's quite old. Math class is a toolkit which is a repository of a series of related functions that all allow you to do mathematical type things. So the singleton design pattern has been around for a long time. In fact, it's probably one of the oldest of the design patterns. Why do we care about learning the names of design patterns and knowing what they mean and do? Yes, sir? Yes, it's a convenient way to engage in discourse with other professionals in our field. Because otherwise we'll show up in the object-oriented programming shop and they'll think we're ignorant because we graduated from Fairfield University and didn't know what a singleton design pattern is. Yes, sir?
Singleton design pattern related, have you ever heard of something called solid?
The solid design pattern?
Yeah.
No, I haven't.
Let me give you the it stands for single responsibility, open flows, list cost substitution, interface segregation, and dependency inversion.
Well, that's not a design pattern. That's multiple design patterns. Dependency inversion is just, we've seen dependency inversion already when we looked at DOM and SACS, because we had to supply end tag and begin tag invocations for the reader to call when it encountered XML. So that's an example of dependency inversion. So solid, it sounds like an acronym for, or a mnemonic for remembering a series of different design patterns. Yes, yes. One of the classic reasons why object-oriented programming is different from procedural programming is because design patterns like this are not possible in procedural programs. Why else might I want a singleton design pattern? There's a reason why we came back to that just now. Yes, it's the registry. And if we go back to registry utils, and we have a looky-loo, we can find a local instance of a registry and check it out. Look at that. Use the singleton pattern and prevent instantiation of the RMI registry utils. So the RMI registry utils is using singleton in order to keep people from subclassing, that is people. What kind of people? Programmers. To keep programmers from subclassing and to keep programmers from making new instances, because we want one and only one instance of the registry. And we're going to have it right in here. And we'll be able to use a toolkit which will let us go through and list all of the bound items in the registry. We'll be able to use a toolkit to restart the registry in case it crashes. We'll be able to use our toolkit to determine if the registry is running. And I have this idea that some of us have already encountered the problem where we forgot to stop the registry before starting it again and got a class in use exception at runtime. So the RMI registry utils prevents that from occurring. So now when somebody calls getRegistry, what happens? He determines if the registry instance is null. If it is, it restarts it. And if it's not null, then it just returns it. So it does lazy instantiation, where lazy instantiation says I'm only going to instance it if I need it, and once I do instance it, I'll instance it once and only once. I beg your pardon? Well, no, because the server, if the first example with RMI used the RMI registry utils, then the first example with RMI would have to have a discussion about the singleton design pattern. You know, I have to start with the simplest first example. You know. And if we looked at that first example critically, we'd say, gee, we had to know an IP address. We weren't able to rendezvous with an arbitrary registry. We weren't able to discover what registries might be available on our network. Think about it a different way. Suppose I had a service called compute bound to the registry on my machine, and then you had a service called compute bound to the registry on your machine. How would I know which compute was doing the computation? I'd have to get the compute bound to the registry on the machine of interest. That's so important because each machine could have a different file system. And in fact, each machine, generally speaking, does have a different file system. And if I want to build a distributed file system using RMI in order to list the files on your machine, I'd better make sure I know the IP address of your machine, or else I'm going to get the wrong files. Let's see if this works. Oh yeah, and it works. Good deal. RMI registry utils. It's a happening thing. So when we start to think about these design patterns, now all of a sudden we start to think in terms of well, what it is we can do with them. Suppose I said to you that there was going to be a serial port. Serial port, that's something we as network communications people should know about. Have we discussed serial ports in this class at all? Not at all? Really? Has anyone ever heard of a COM port? A COM1? Heard of it? Never used it? Really? You guys never heard of a serial port? Serial port is a physical layer mechanism for data transport. It focuses primarily on moving bytes from one point to another. So it is a mechanism for doing point-to-point protocol, PPP. And so if you think about it, there's no routing, there's no addresses. The only thing you need is a proper port name, a subroutine library for accessing the port, and a way of establishing the speed of the port, a mechanism for establishing the error control protocols used by the port, a mechanism for establishing the handshaking for flow control used by the port, the number of framing bits in the port, and what else? And the number of data bits in the port. And once you have all of that information, then you have configured the port properly, and then you can proceed to send data to the port. And presumably the receiver of that data will know what to do with the data, and will have the correct configurations for the port, and then you'll be able to do basic communication. Some computers, perhaps most laptops nowadays, do not have a serial port. I think all the modern Macs are without it. I would say even all the modern Windows desktops are without it. However, it's a waste of space. But there are USB interfaced serial ports, and you can use these things in order to gain access to embedded devices that have serial ports for communication. Like, for example, all of the armed robots in, they're not armed, one-armed robots in McAuliffe Hall have serial port interfaces. So if you look at like the lathe over in the machine shop, that's the Haas machine they call it. It looks like a machine that could pretty much use numerically controlled milling to go through nitride and steel. Very heavy-duty machine shop machine. It has a serial port. You want to communicate to the Haas machine. This is a brand new machine. Comes with a serial port. You want to communicate to I think there's a lathe over in the Automated Manufacturing Center. Has a serial port. Very common to see these things in desktop computers. For example, on the desktop computers, as I look around in the room here today, I see a 15-pin D-connect. And it's a D-connect because it's got a little D shape to it. And that is a COM port. That's a serial port. If you go to the Arduino and plug it into a USB interface, it looks like a COM port. And it even uses a serial port interface chip to the USB interface called an FTDI chip. And so serial port elements can be addressed in Java through three almost compatible APIs. Almost compatible APIs. The first one is called the javax.com API. The second one is called the RxTX API. And the third one is called the JNA API. The javax.com API is the one that first came out from Sun for addressing the COM ports on different machines. That would enable you to have a portable API, a platform-independent API for communicating to COM ports. Sun has abandoned any maintenance of the javax.com API, but after they created the specification, it was embraced and extended by the open source RxTX group. Their GNU implementation is in the gnu.io package, and they give you all of the COM port drivers and interfaces and identifiers so that you can proceed to open up communications to a COM port from within Java. I myself have been contributing to the serial port package regularly, and have created my own mechanism for communicating to COM ports. And instead of using a DLL, or shared object library, that you link to through Java native interfaces, also known as JNI, which is a mechanism for within Java invoking subroutines in C or C++, I've been using what's called Java native architecture. With a colleague, we have been able to come up with a mechanism that is a little bit more friendly when it comes time to running multi-platform COM ports. There's another means of communication also available on all these desktops. These are 25-pin connectors, and they've got a little icon of a printer next to them, and they call them parallel ports. Some people would call them printer ports. And these give you a high-speed parallel interface to... Does anybody actually use printer ports nowadays? All the machines have them still. He's still high. Someone said it's a waste of space. Now, that's a waste of space. No kidding. But we also have access to those through the same API. And what you can do, what can you do with that? Well, you can take an LED and you can plug it into one of the pins. You can take the other pin and put it into the ground. And you can turn the LED on. There's actually more practical things you can do with it. But that's one of the things. You can individually control the bits coming out from the parallel port. And it's relatively high-speed interface. So that's kind of neat. What I ended up doing with my Java native architecture mechanism is I came up with what's called a pure Java communication protocol. And that enables you to do things like communicate to external modems. I can dial the phone automatically, navigating through voice jail, which is one of my pet peeves in life. I hate voice jail. So this lets you automate all of the communications through the voice jail. In theory, I should be able to run an address book program. Here's my address book program. Now the question becomes whether or not I can gain access to a serial port. And there it is, COM4, the serial port. So now I have selected any one of the COM ports. There's only one in this case. If I had an external dongle, I could get some more. I can pick out the baud rate. Ah, boy, nomenclature. I love this field because there's so many different, really exotic sounding words for very simple ideas. So what's a baud rate? What's a baud? Networks people here, you should know what this is, I'm thinking. You never heard the term? How many people here have never heard the term? Oh, you've heard it. You've heard the term baud rate. So now it's time to learn what it is. What's the baud rate? What does it mean? Is it the number of bits per second? Symbols. It's symbols per second. So is a symbol per second the same thing as bits per second? No. Why not? You're reading something, aren't you? Yeah. Oh. That's cheating. You sound so authoritative. I'm very impressed. Yeah. So as it happens, if you know how many bits there are per symbol, then you can know how many symbols there are per second. So if you told me that every symbol was as probable as every other symbol, and there were 256 different symbols, then I would say that each symbol has 8 bits. So if you told me you were getting one symbol per second, I would say it's the equivalent of getting 8 bits per second, because the log to the base 2 of the total number of equiprobable symbols is equal to the number of bits that you have per symbol. And the log to the base 2 of 256 is 8, because 2 to the 8 is 256. So as a result, if you told me, well, gee, I have a 1024 symbol set, or symbol constellation, then I'd say, great, log to the base 2 of 1024 must be 10, because 2 to the 10 is 1024. How many symbols per second do you get? What's your baud rate? You say 10. And I say, aha, so you're transmitting at 100 bits per second. So that's your symbol rate. So then comes the number of data bits. Data bits are going to be grouped together in characters. And those characters can have 8 or 7 bits. In this case, actually 5 bits. I've never seen anyone use that, though. Then you have error control. In error control for RS-232, there's only one kind of error control, and that is called backward error control. Error detecting codes that are used in standard RS-232 ports consist only of 1-bit codes, and those are called parity codes. 1-bit parity is going to be either even or odd. With even parity, you add the bit in order to make the entire code word have an even number of bits. With odd parity, you add the bit in order to make it so that the entire code word has an odd number of bits. You compute the parity by using the exclusive OR operation across all the bits in parallel. So you take all the bits, you do an exclusive OR, and then that gives you your parity output. If you want even parity, you put an inverter on it and use an exclusive NOR. Stop bits are what are called framing bits. Framing bits are involved with taking the character and putting well-known bits before and after the code word so that you can see when the code word begins and when the code word ends. Because what happens when you transmit binary data down a single wire is the on-off signals have no clock. As a result of having no clock, they are said to be asynchronous. Asynchronous means without a clock. And asynchronous signals need to have some sort of a bit clock on the receiver. And that bit clock synchronizes with what's called the framing bits as they come in through the wire. So the RS-232 receiver, which is also called a UART, or Universal Asynchronous Receiver Transmitter. That's usually a chip, although here in the new age they probably just have it on the motherboard. There's what they call a baud rate clock, and that baud rate clock is just like a regular clock with a difference, and the difference is it's got a sample and hold on a phase lock loop. And that sample and hold looks for those framing bits coming in and resynchronizes every time a character comes across so that it can make sure that when there are several zeros in a row, it knows when the bit interval slices have changed. So it has to be able to sample at the center of each one of the bits as they march across the wire. And so what that means is it's got a clock in there that says, okay, is there a 0 there? And then it goes, has another clock comes up and says, okay, is there a 0 or a 1 there? And so it's trying to find out where the center is of the bit as it marches across the wire. That bit clock has to be correct, or else you're going to have a framing error on the receiver. And you can choose the number of stop bits. And then there is either software flow control or hardware flow control. Isn't RS-232 wonderful that it gives you all these choices? And as a Java programmer, flow control is done with Control S and Control Q, or X on, X off. These are the RS-232 ASCII symbols for determining when to turn off the transmitter because you're being overwhelmed, and to tell it, slow down, I can't keep up. If you're a little 8-bit toaster controller like an Arduino, that could be really useful, especially if you're being swamped by some high-speed baud rate coming in. There's a hardware flow control too. The hardware flow control is done with separate control lines. That's why there's 15 pins on a COM port. Those separate control lines include ready to send and clear to send, RTS, CTS. And so you say use the hardware or software flow control. And if you're using the hardware flow control, you use RTS and CTS. Although here you can have combinations of software going in and hardware going out, or hardware going in and software going out. So you could mix it if you really wanted to get exotic. I picked none because in general I'm communicating at a low baud rate to an external modem. My goal is to dial the phone. All I wanted to do was dial the phone. This gives you a little insight into how pissed off voice jail makes me. I've spent a lot of effort dialing the phone. Now I don't have to, have to worry about it. There's another preference you can set up. You can dial with different touch tone speeds. With modems, you can change those touch tone speeds in hardware. If you want to dial with your speaker using a touch tone, you're using what's called the DTMF system, which is dual tone multiple frequency. That gets decoded by the central office and allows you to route your phone through the virtual circuit switch system into somebody else's receiver. Once that connection has been established, you are guaranteed a quality of service. That's the nature of a circuit switch network. Skype doesn't do that, by the way. Skype does a packet switch network. But the real phones, the non-voice over IP phones, they're the ones that'll give you a proper virtual circuit switch network. So in theory, I should be able to do a speaker dial. I haven't done this in a while. Can you hear it? It was a little low, but who am I calling? I'm calling information. I always call information. I say, oh, could you tell me the 30th digit for pi? I wouldn't know that, sir. Isn't this information? So that's what happens when you use the standard touch tones. It turns. I beg your pardon? No. I haven't got a phone hooked up to the speaker here. So if I had a phone hooked to the speaker, then it would dial the phone. If I wanted to use voice over IP, then I'd need something else. I wouldn't need an external modem to make the phone call because I wouldn't have a phone line. If I was going to use voice over IP, I would need what's called a SIP bridge, which stands for Session Initiation Protocol. That's a whole other lecture. SIP bridge. Yeah, this. I use SIP at home. I have what they call call-centric. Have you guys ever heard of this? Call-centric? Call-centric is a voice-over IP phone service that uses a SIP bridge. And what that does is it gives you a device that plugs into your network and plugs into your telephone system. And then when you pick up the phone, you get a dial tone. And then everything else is sounding like a regular phone, and you dial normally but in fact it's using the network in order to get phone services. That's what a SIP bridge does. So, you know what it's like? Magic Jack. This all dates back from before Magic Jack. Have you guys ever tried Magic Jack? Does it work? I tried it once. It sounded like everybody I was calling was in the Mideast or something. It was terrible. It works okay? You like the quality? Yeah? Cool. Yeah, maybe I should try it again then.
It's good for long distance.
Long distance, but not local.
I mean, we do it for local, I guess, but I wouldn't use it for long distance.
Okay. You know, I use Skype, and I think it sounded really good when I called Kyle, but if I used... Didn't it sound good? Yeah. Kyle was in Galway, Ireland, and we were doing long sessions, like an hour, and it was all free, Skype to Skype. He's a study abroad student here. We're going to fix your credit hours, by the way. Yeah, I already got an email on back. Chris Johnson agreed that your credit hours will be correct. I knew it would work out. Everything works out for the best. No reason to get excited.
We were saying to sue people yesterday.
Sorry. I got real pissed off. So they shortchanged him on his credit hours after he went and studied abroad. After they agreed in writing what the credit hours should be. And I said, that's not right. You can't renege on that. It's not correct. So that I think we ran out of time here, but I got a lot of I'll say territory done. So let me summarize. We did an RMI computation. We did it over the network. We were able to run the registry. We did the singleton pattern, which I thought was good. We then had a little discussion about what serial ports are, right? Which I thought was also very good. A detailed discussion about how you configure the serial ports, and you can just envision what the data structure looks like for things like storing the baud rate, the flow control, the number of stop bits. I mean, there's like data structures that have to be serialized on that. And in fact, I don't know if you noticed, but in the background over in here, you can see sort of this thing that's going on where I changed the speed and it converted it to XML and serialized an instance of an object and printed it out onto the console. That's the kind of thing that's used for doing persistence in your graphic user interface. Because when I start the graphic user interface, I don't want to have to set up my COM port every time. I want it to stick. And so even if you know, I run it 2 years from now, presumably if I haven't wiped my hard drive or something, those preferences are still there. And I would really like it not to have to keep changing baud rates. That's not reasonable. That doesn't give me a good, how would you call it, user interface experience. Right? That would not be a good experience. So if you were a network programmer and you wanted to interface to something like the Haas machine, it would be really good for you to say, aha, that's a COM port, and I can plug into this. But then the question becomes, how do you know a COM port when you see one? Tricky question. COM ports have been around since the 60s, the serial ports. And the serial port standard started with a 25-pin D-connect. Apple appropriated it when it came out with the Mac and used it for its SCSI interface. Form factor identical. You can plug your RS-232 port right into the mainframe, the main motherboard of the Mac Plus or Mac SE, and completely blow it out because it's 10 volts going into a 5-volt input. Because COM ports, RS-232, that's 10 volts, plus minus 10 volts, in fact. And if you think about it, what a bad choice they made. But they had these connectors and they decided to use them in life in the big city. So COM ports, serial ports in general, are an absolute circus. 3-ring circus with clowns. And you can find them in 15-pin D-connects. You can find them in 25-pin D-connects. You can find them in circular 8-pin D-connects. And you know where you find them most commonly in circular 8-pin D-connects? Roomba robots. They all have RS-232 or RS-422 interfaces with circular 8-pin D-connects. You can see a little, if you have a Roomba vacuum, you can pick up the little cover on it, and you can plug in they call it Bluetooth, which is a Bluetooth interface for your Roomba. And then you can drive it around the room, sucking up dirt, chasing the cat, or whatever evil things you would do with a robot. Probably it needs a gun, right? And then they already had this, right? On Sons of Guns, they had a drone helicopter, and first thing they did was they put a machine gun on it. It's like, boy, are you guys nuts? What does the FAA say about that? Nothing good, I imagine. Civilians are not supposed to have armed drones. Then at the end they said, this is not for sale, it's just a research project. Oh yeah, sure. So then you can find RS-232 on every, what do they call these things? Quartus DE2 board. They have RS-232. So if you take Digital Design 2, you'll find RS-232 is there. You can also find RS-232 shields for all your Arduinos. You can get them for your Raspberry Pis. They're very common. So RS-232, very common. RMI, a way to communicate to remote machines. So now if you have a remote machine with a serial port hooked up to a robot, you can use RMI to communicate to it and send commands off to your robot. Huh? Yes, sir?
I was just going to add that RS-232 is also common in industrial products.
Well, robots are industrial products too. Yeah. Well, and modems, they're everywhere. You'll find them all over the place. I don't see a lot looking around the room because we're not in McAuliffe 203, but if we were, we would see the SIR1 controllers all have RS-232 interfaces on their fronts. So that's what I have for today. I would like to ask you to read the paper on Centa-J, which is on my website. And also, you should be finishing up with your reading on Chapter 43 in the Java for Programmers book. Yes, I can certainly do that. All right, thank you.